Okay, now that we've completed our review of pointers, let's go back into C++ versus Java. All right, we're talking about the destructor, special signature with a tilde. Wow, the tilde has disappeared from these slides. There's supposed to be tildes there. Okay. Ooh, oh, this is good. All right, let's go ahead and copy the destructor.cpp to copy.cpp. So we still have our old code. And we'll have get, oh no, we'll still print out the 2. Okay. If I were to make structures S3 equal to S2, what is that doing? I see why you think that, but not quite. What is S3?
S3 is a
Pointer to?
It's pointing to the first thing in that S2 array.
You could think of S2 as an array, but S2 is just a pointer, and yeah, it's pointing to what S2 is doing. Literally, it's copying the memory location stored in S2 and putting it into S3. So if I go down here and I type in S3, what would you expect it to do? Ooh, let me actually fix this over here too. Correct. So let me -g copy.cpp. Oops. -o copy. Let's see if I can. Oh, good. It compiled. Let's go ahead and run it. All right, boy, Johnny. Do I have any memory leaks?
Yeah. S3, right? Yeah.
Nope. Why don't I have any memory leaks?
Because you're deleting S2 at the bottom.
Right, I didn't create a new structures. I'm just pointing to it with a different variable. I've created an alias is what it's called. So I didn't allocate a new structures object. I just copied it over. This is a shallow copy because I'm being shallow. I'm just copying a pointer over to it. I'm not copying the entire contents of structures into it. Come on in. Welcome. You can go ahead. We'll just all stare at you as you walk in awkwardly.
Okay.
It's just Damon. He's the online student.
Yeah.
Got it.
Right. So I just copied the memory location over. All right. On the other hand, if I wanted to do what's called a, well, let me go down here and label it shallow copy for you. Whoops, that's in all caps. Shallow copy. Because I'm just copying the pointer over. All right, we'll do a deep copy. But in order to do a deep copy, I need to change the constructor. Structures star S. So now S. Oops, I didn't mean to put the ampersand. Let's put that. M height. S M width. And new string copying over S M name. Okay? So this is going to do a deep copy because it's going to take the contents of whatever I passed in and make a copy of each of its variables or each of its contents. So down here, S3 is a shallow copy, but if I do this, structures S4 equals new structures, and then we'll pass in S2. Deep copy, because I'm actually creating a copy of everything. Notice I'm creating also a new structures on the heap. Now if I'm down here and I print everything out, should I get the same thing to print out? Yeah, because I'm still copying everything over. So that hasn't changed.
But
You're gonna have a memory leak, right?
But you'll have a memory. Perfect. All right. So hold on. No known conversion, type argument 1 to structures. Let's see what we did wrong. So that's structures with an S. Whoa. And a lot of times C++ will give you the giant error novel. So I usually hit enter a lot. Go up to the top. Error, no matching function called to new string. Oh, okay. Because it's a pointer. It doesn't want a pointer, it wants me to dereference that. And that's fine. So we'll dereference that. There we go. So S4 is boy Johnny. .get height is 10. And then as y'all pointed out, if I run it, I should have memory leak because why do I have memory leak?
You didn't delete S4.
You did delete S4.
So I have a question.
Yes.
Shadow copy. It will only copy over exactly what S2 is pointing
In this case, yes.
to. Okay, so, and that would be the name only in this case, right?
No, it's just copying over the memory address of S2. It's really making an alias. Because S3 and S2 now point to the same thing. The other issue here, now let's stick with it this way, because it's going to get really confusing really fast. We're just going to call this shallow copy and that deep copy for now, because S3 is just storing the memory location S2 was storing, and then S4 is now actually creating a new structure on the heap. All right.
So if we were to just call S3 itself, it would give us a memory location.
Yeah.
Okay.
So if we go down here and we go, let's see, cout S3 equals S3 and then backslash n, and we'll do S2. Are they going to print out the same thing? Oops, let me not run Valgrind, let me actually compile and run it. Yep, same memory location. Because they're both storing a memory location of the structures or structure that was created up here. So once the structure is made on the heap, the memory location of that one is stored in S2, and then we're copying that memory location from S2 and storing it in S3. Over here, we're constructing an entirely new structures on the heap and using the constructor of structures that's namely, that's passed in a structures right here. So we run code to copy everything over and actually create a new string as well.
And that's a whole new memory location.
And that's a completely new memory location, and even a new memory location for the name.
Makes sense now. It makes better sense.
All right. Any other questions? Whew. So y'all used to methods. That's good. We created some methods right here. You can do method overloading. I cannot see. Oh, we do have method overloading. What method is overloaded here? Or overloaded.
Structures.
Yeah, structures. So the constructor structures has 3 different signatures. So C++ does detect which function to call based on the parameters you pass to the function. There's something called operator overloading, but we'll get to that later. Okay, I guess it's going to tell you right now. I'm only going to show you this, and we'll get to it later, and we'll talk about it a little. You can rewrite what equals, plus, stars, and double equals mean in C++. Again, you can overwrite what equals, plus, star, and double equals mean in C++. You can change the function that's being called when you use that code. Why is this helpful? Let's say you make a matrix and you have plus, then you can actually have plus call a matrix plus operation, and that makes logical sense. Can this ever have issues? What issues could this have?
You could redefine plus to do something else when you just want it to do what it's.
Right, you can redefine what the addition of two integers means. Why you'd want to do this? I don't know, but it's legal. And you can define what equals does, that's also great. And double equals.
Is it only those that you can define?
No, you can redefine division, modulus. Oh man.
Pretty much any.
You can, yeah. You can redefine I think you can redefine dereference as well. There's a lot of things you can redefine. They really went overboard on this one. Really went overboard. Method binding, all right, this is going to never come up in this class because we're not going to deal with it. But just so you know, C++ binds things differently than Java. So the first one, in Java, you have employee equals new teacher. Now keep in mind that employee or teachers inherits from employee. So teachers is an employee from this example. I'm not showing you that code right now, but before I do that, you got to figure out what's being called. And in C++, you're doing the same thing. Teacher, again, inherits from employee. So the question is, when you call e.promote or the C++ equivalent, dereference e.promote, which promote method is being called, teacher or employee? Let's say that both employee and teacher have a promote function. So in Java, the teacher function would be called because you created a teacher object, and therefore it's going to call teacher.promote. Excuse me. In C++, since the pointer is an employee, it's going to call employees promote. Hopefully, well, you're never, for this class, you're not going to have to deal with this. It's not going to, well, you might run into code where you do this, but all those labs and projects I do, you can easily solve without running into this problem. We're not doing huge inheritance hierarchies in this class. But the point is, C++ being compile time is going to call employees promote. Java being runtime is going to call teachers promote. Because Java is going to wait till the object is created and then determine which functions to be called. C++ is going to determine the function to be called when you are compiling the program. Anyone confused? Kind of?
I think it makes sense. It's just the difference is how it's compiled.
Right, it's how it works.
Yeah.
All right. But this is going to come back when we do generics, or generics, I should say, templates. So this will make more sense later on. There are tons of features, but there's no way I'm going to get to them in time. You look up the C++, I guess, standard language specification is probably the thickest one out there. There are tons of features, and there's tons of little gotchas here and there about how the language works. But we're just going to try and stick with the simple version for now. And if you ever get on a project that uses C++, you should be able to pick it up. All right, there's 2 labs today. So I'm not going to assign you a project. There's just 2 labs. But they're both array labs. So lab 4 is a review of arrays. And then lab 6 is going to be doing arrays with objects. I'm going to go over the 2 labs, and then I'm going to go over some coding examples with C++ because we did skip over a couple things, namely how to do header files and the fact that in C++ you don't have to have, your functions don't have to be a member of a class. And also I didn't talk about how you do header files with classes either. So I'm going to talk about that after I go over these labs. Yes.
So just to recap, just to make sure, so lab 2 is due today, lab 3 and 5 are due Wednesday, and 4 and 6 are due Monday.
Oh, wow, that's gonna be a busy week. Yep.
Okay, just check.
But nothing's due this Wednesday?
3 and 5 are due this Wednesday.
This Wednesday?
Yeah.
Nice. All right.